So this is the questions. Okay, have I not shared my screen?
No, sir.
Okay, now look at it. I'll share it now. So these are the questions I sent to you, all of you, right? Correct? Janani, Nitya, Srushti, Vandita. The boys haven't joined yet today. What happened to the boys? Preet, Sampreet, and Ariel Arti Pereira. She's also not joined. Right? Shall you wait for 1 or 2 minutes more, or shall you start? What do you guys say?
Sir, we should start the session.
We'll start. Okay, fine. Definitely we'll start. Okay. So let them join a little later because we must need to, people who have joined early, we should not waste the time. Okay. Any questions on this? Okay, Shushti has said definitely we'll go to the numericals. I have planned to do as many numericals as possible today and make it easy for you guys. Okay, Aarti has joined. Good evening, Aarti. So just wait. I think let her settle down. I could see she has joined. Hi, Aarti. Good evening. Can you hear me? Are you settled down? Aarti, are you there? I could see her. She is logged in. Just wait for a few seconds. Aarti, if you're there, can you unmute yourself and say hello to all of us? Yes, Aarti.
Hello.
Hi, Aarti. Good evening. Just waiting for you to join. We're about to start. Okay. Do all of you go? Did all of you go through these questions? I've sent the questions. This is basically I call them basic questions, like to know the basic concepts about this chapter. Have you gone through cursory overview of these questions? Because this
Sir,
will.
I have not prepared for this. I have just got them. I just logged in and
Oh,
saw your mail.
okay, 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 fine, no problem. So if you are okay, not an issue. I'm just assuming now, people who have not seen my questions, I'm just assuming that you know most of it. At least the concepts you know, right? Okay. For all of you, for all benefit to all of you, I mean, I think the two people have yet to join. You will not wait for them. Okay. Now, I'm not going through these questions again. So just quickly take you through that the whole chapter is about specific heat capacity and specific latent heat, right? Or basically the heat energy that is required to increase the temperature and the heat energy that is required to change the state. Am I right? So this is the fundamental things what I have shown on the board is for the entire chapter. Anybody has any doubt in this, just let me know because we are going to use this concept in the numericals. Okay. So I'm not going to read through everything here. I mean, it is quite evident. I'll just give you 1 minute to read through everything and ask me. Pete has joined. Yes. Hi, Pete. So, and at the bottom you see there is a statement. Can you, can anyone tell me what is this statement mean? What is this?
It is the principle of mixers.
It's a mixers or in general it is also known as principle of calorimetry. Okay. Right? Principle of mixers and principle of calorimetry. Okay. Good. Any question? Do you have anybody on this? Now, I think you guys all know Q equal to MC delta T, right? And Q
Yes,
equals to
sir.
ML. Fine, good.
Yes, sir.
Okay. So what I will do is I will just introduce one thing. I know that most of you find this difficult. Okay. And I have found out that many of the times you find this difficult because of identifying which is changing, where you have to use specific heat capacity or where you have to use specific latent heat and
Yes,
how you have to use, right? Am I right? Correct, no?
yes,
Yes?
sir.
Okay. Good. Preet, are you there? Preet is offline. He's not joined. I think he's trying to join. He has some technical issue in the last session also. Okay. Fine. I have shared the link also, the YouTube, right? What we were discussing. Today also I'm recording the sessions and after the sessions I'm going to share. Okay. Now, what I'm going to share with you on the board, a simple thing. Just a minute. Give me a moment. What is this? For each of these numericals, for all of you, I don't know how you guys are doing it, but I would suggest if you can follow this, your calorimetry would be very easy. And I'm going to use this table to solve each of the numericals. Okay, so let me tell you. In principle of calorimetry, some objects gain heat and some objects lose heat. Correct, no? Right?
Yes.
Yes. So what I collect here is only the information. We try to identify which of the objects are gaining heat and which of the others losing heat. Now, take for example, we'll do that. We'll do on the same board with a simple example, and I'm going to explain this again with the help of that numerical. Now we find out whether that, so some object is gaining heat, some object. So you just identify who is gaining it and fill that column, and then it could be either gaining or losing. It cannot be both. And check whether there is a state change. If there is a state change, then the initial temperature, final temperature would be same. And we will be using L stands for specific latent heat capacity, and specific latent heat and specific latent heat, and C stands for specific heat capacity. Correct? No. This identifiers
Yes.
you guys are aware of it, and we'll see the mass of that object. Right? And you've seen that Y mass. In the previous board, you have seen that both the formula to calculate the energy, you need mass M. Right? Anybody who has not understood what I have explained in the this table, please feel free to let me know. I can explain it again. But it's fairly simple, not a difficult thing to understand. Fairly simple, right? So can I assume everybody has understood this and how to feel it? I'm going to do it right away. Okay.
Okay.
Today Samprit is absent. I'm not sure why. Anyway. Okay. So let me take up the very simple example for you guys to understand this particular concept. Just give me a moment. Yes, let's do this question number 5, and I'll do. Okay, here's the question, all of you. Just read the question for half a minute, then I'm going to ask you short questions to fill this table.
So your voice is not clear.
Is it, my voice is not
It's
clear?
breaking, sir.
It's not clear, just a minute, let me check.
Now it's clear, sir.
Okay, fine. So I repeat what I said. I said that
Yes, sir, now it's
read this question, and I'll ask you I'll take your help to fill this table. Okay, all of you have read, right? So in this process, what is happening? The aluminum vessel. So let me pull it a little down. It is covering my. Okay. So what is happening here? An aluminum vessel of mass 200 grams contains half liter of water at 298 Kelvin. Calculate the amount of heat required to raise the temperature up to 75 degrees centigrade. Okay. So who is gaining heat here? Is aluminum gaining heat? Yes?
yes, sir.
Okay. Now, is there any state change? No.
No.
What is the initial temperature? 298 K. So you see that the
Yes.
temperature has been given in two forms. Either you take in Kelvin or you take in centigrade, not mix up. So since it is given, all the values are given in centigrade, so we'll take it convert this 298K in the centigrade. So what is 298K? How much is in the centigrade? 298K be 298 minus 273.
Minus
Empty.
How much is the centigrade? It is 25.
25.
Wonderful. So initial temperature I am writing is 25. What is the final temperature?
Final
75.
75.
Wonderful. So if there is no state change, state I can say it is the specific heat capacity, right? So what I'm doing here, I'm not writing the specific, I write it here, the identifier, the specific heat capacity as CA, right? Hmm?
Okay.
So A for aluminium.
And CW.
Yeah, yes, you're right. We'll do that when you do that. So CA equals to what is given? 0.21 calorie. So it's basically 0. If you don't get the space to write, so you just write CA here. I would rather prefer you to write CA just here and then write CA on the board. So CA would be here 0.21 cal gram per degree centigrade, correct? No? Now what is the mass given is 200 gram.
200 grams.
So we give an identifier MA. A stands for aluminium. So I write it here MA equals to 200 gram. Wonderful. Now water. Water is also gaining heat or losing heat?
It is also gaining heat.
Wonderful. Water is also gaining. I'm just setting it W. So no losing heat. No state. Is there any state change?
No, sir.
No. What is the initial temperature?
It is also 25.
It is also
25
very.
Eastern.
What is the final temperature?
And also 75 degrees.
75 degrees centigrade. And it is CW and it is
And
MW.
W.
So what is CW here? CW for example 1 cal
1
gram per,
calorie.
yes, wonderful, and MW is it is
500
given
grams.
500 gram. No, what is it 500 gram?
Half liter, sir. Half liter of water.
Ah, right, you're right, half liter. So it is 500. How could you say it is 500 gram? The volume
The
has been
density
given.
is given. You just
Yes, very right.
Yeah.
So we just write what was given first. Half liter means 500 cc, correct? So 500 cc means since density is given, mass is equals to dW. Oops, what is happening? Is dW into VW, right? No, you know that density equals to mass into mass upon volume, and mass would be equals to density multiplied by volume, right? I should write it not density is rho. So what is becomes? It is becomes, you're right. If you do 500 into 1, you get 500 gram. Okay. So now we know that. So for Q aluminium, write it M aluminium, C aluminium, and temperature change. So what is the temperature change? 75 by 25, correct? Right? No? Am I audible?
Yes, sir.
yes, sir.
Okay. Fine. So just find out the value here. So MA equals to 200 gram, right? And okay. Now, do we need to change the units or you're good? Everything is given. Is there any mix-up? We have found out one mix-up with the Kelvin. Now, is there any further mix-up?
Kelvin.
No?
No,
No.
No. So then we can use it. So
it,
what is the energy we'll get? In
2000 calories.
calories you'll get. Yes, you are right. So Ca is become zero point 0.2 and you'll get it 50. So you're getting 2000 calories. Similarly, what you get for QW, MW, find out. I think we are already done, right? Correct? Hmm? Oh, today is some problem with the board. I'm not able to write How much you get here?
2,500.
2,500, right? Okay, here you get 500. One. No, we're getting more.
It is not 2,500.
No, you're not getting 2,000. You're getting more. It's a
It
500.
is 5,000, sir. It is 5,000.
Let me
5,000
see. No,
calories.
I don't think so. It is 5,000. It is 50, right? So do
It's
28,000 here.
25,000.
Yes.
Yeah.
5,000, yes, yes.
So what is the total amount of energy required? QC, QA plus QW, right? So it would be 27,000 calorie,
Mm.
right now. Correct? Okay. So you know how,
But sir, it's only asking the heat required to raise the temperature of water.
no, but along with that heat, since it is the same, right? It's in the aluminum vessel. So
Yeah.
both will be has to be taken to the centigrade degree centigrade, right? They are mixed up in the same.
Okay.
It's a mixture, right?
Hmm.
So both you have to consider.
Okay.
The temperature, can an aluminum vessel be a different temperature when you raise the water temperature to 75 degrees centigrade? Cannot be, right?
Yeah.
Got it, no? So total energy required
Yeah.
is 27,000 kilocalorie, calorie, right? Got it, no?
Yes, sir.
So I picked up this simple numerical just for you to guys to explain this table. Okay. So let's do. Anybody has any question to any doubt
No, sir.
how to use this table? Okay. So
No.
in this case, it is quite simple to use the table. Now you'll see that when you do where the multiple changes are happening, how this table is going to be useful for us. Okay. Let's look into that. Okay. So let me get the another question now. Now what I'll do is like yesterday, I will have one of you, no, uh, assisting me to do the numerical, and the rest of the people will do on their board on their book, and then let and pass the answer to me. Okay, let's see. Okay, so today the system is little slow for some reason. I don't know why. I reported this. I don't know whether you guys are feeling that as well, but I reported this to the technical team. So there is some changes that are happening. Okay, so I pick up the table as well and then use it for our numerical. So I'll do it here. I'll keep it on the right hand side. Okay, who will volunteer with me? Read the question and volunteer.
Sir,
Okay,
sir, I'll do it, sir.
fine. Okay, Janani, be with me. So you have to again find out who is gaining heat and who is losing heat and what is the details part of it. Okay.
Sir, actually, your screen is not actually visible.
It's not visible.
Yeah, it is showing the previous problem.
Oh, is it?
No, sir.
All of you? All of you is the problem? Everybody is facing the
Yes,
problem?
it's showing the previous tab.
Okay.
Yeah.
Yes, sir. Sir, it is showing the previous problem.
It's still showing. I have just put to your new board. Is it showing? Okay, what I'll do is let me share it once again. Are you showing the board number 4 or board number 3?
Board number
3.
3.
Oh,
So it just
can
refreshes me.
I'll just
It will
refresh
do
it.
also.
Yeah, refresh it. taking some time to refresh. Today is a little bit slow. Okay. So what I'll do is, for all of you guys to read it, I will just copy this on in the chat window, okay? And you guys can do this. At least read the question right now. So I'll just put it on the chat window. You can messaging window rather. So let me put it. So I just passed it to messaging window. Are you able to see all of you? Just read it as it is loaded. It's taking some time. You can just read this. Can you guys hear me?
Yes, sir.
Some network error. Have you guys read the message? It shows me some some. Okay, it has been re-established. Okay, it gives me an odd message saying that my network is not on. But I'm able to talk to you guys. You're able to hear me. So, are you guys? You just do that. Let me sort out this problem. Is my screen visible now? It is completely blank, right?
No, sir.
No, sir.
It's not blank, it's showing the previous tab, board number 3.
Okay.
And it says the organizer is experiencing technical difficulties. Unless the organizer rejoins, the meeting will end in 5 minutes.
No. Wait. Something is a problem.
Yes, sir. Now your screen is visible.
Not visible, but you are seeing
Yes,
the
sir.
Yes.
nothing is there, right?
No, we can see the question.
Yes, sir. We can see the question now.
Quite odd. I am not. For me, it is showing nothing. It's showing page number 1. something is
Yeah,
wrong.
even we are.
Even
Now
Now
you?
we are
it's
also
blank.
seeing a blank page.
Okay, leave it. Then I'm
Yeah,
just.
now.
That's okay. That's okay. Let me. That's fine. It has been recorded what you have done in the previous one. So let me upload the question again here. Okay. But have you guys? Are you guys reading it?
Okay.
Oh, it says please wait until you connect with the server.
Yes, sir.
Hello.
Yes, sir.
Some disruption, technical disruption. So let's find out what's the way. If it continues, then probably we have to reschedule the session again sometime. I just need to get the signal from them. So let me try to refresh, make the page again. Let me see. Okay, are you able to see this now? Looks to have something is resolved. Are you able to see my page right now with the question?
Yeah,
Yes,
it's a
sir.
blank page. Yeah, now. We can.
Now it is there?
Yeah, sir.
Yes, sir.
Okay, it is saying that please wait while you make this downloaded. Okay. But it is not allowing to move to anything. Okay, fine. Let me ask you this question. I guess you guys can do it. I can still help you guys to do it. So you got the table with you, right? Correct? No?
Yes, sir. We have the table.
Okay. So which objects are gaining energy and which
So
other?
can you just imagine it?
I'll do it. I'm trying to do that actually. It is not allowing me to do because of the technical issue. What's the problem? I'm just taking off this sharing screen for some time. Just take the instruction from the from these people. Okay, so don't see that I'm not there. I'm still there. So which object is okay? Let's talk to you guys. Which object is losing gaining heat? Hello,
Paraffin.
aluminium,
So, aluminum?
Aluminium and paraffin.
aluminium and
Yeah,
paraffin.
aluminum.
Yes. So so aluminium and paraffin is okay. Now okay, I think I have copied the wrong one. Just a minute. Let me copy the right one. Yes, I copied the wrong one. The one that I copied to you, or the message you is the wrong one. So it is okay.
Thank you, sir.
Hmm? You got the question now on the messaging window. So paraffin, what is the
Yes,
Yeah.
sir.
initial
Yes, sir.
temperature?
Yes, sir.
Yeah, initial temperature of cylinder, and it is very similar to the one. If you guys, anybody has got the answer, anybody who is finding difficulty, let me try to help out with the technical issue is there. Okay. Oh, again gone basically. It is not allowing. Okay, I just mute you guys. I need to talk to the Vedantu to find out whether it can continue today or we have to reschedule it, because the technical disruption continues like this. Then it's better we reschedule this class. Okay. Let me talk to Vedantu. Okay. I'm just muting you guys. Hello guys, can you see my no screen now? Hmm?
No. No, sir.
No?
Yes, sir.
Okay, fine.
Yes.
Okay, so it seems to be some something they have done is seems to work. Let's see that I already sent an SOS to guys to others. So I'll see that in some one of the sessions we'll extend it little. Is it okay in some days we can extend this little half an hour more to cover up
Yeah.
something? It's fine, no? So we'll do that. I'll try to see the
Yes, sir.
feasibility of that, and then we'll do that because I'm really feeling bad for this because it's taking unnecessary time. Okay. Nothing in my control. It can happen, right? Not an issue. Technical issue can happen. Okay. So which gains? Anybody got the answer? Nobody has got the answer in the time. Nobody could do.
Sir,
No.
actually, cylinder is, I mean, the brass gains the heat, right?
Yeah. See, was raised to 100 degrees centigrade and transferred to a thin. So okay, let's see that. No, first of all, anybody got
So
the answer?
if you're transferring, is there a heat loss?
Oh yes. How can you transfer
Of how
heat?
much?
It's a loss.
No, by how much?
Okay, we'll see that one by one. We'll see that one by one. Okay, let's see that brass cylinder. So brass cylinder is it? What's happening to the brass cylinder? Is raised to 100 degrees centigrade. Correct? No. Hmm?
Yes.
And transferred to a thin L. We don't know how it has been gained. Okay, we don't know from which temperature it's been gained. Correct? No. So what happened is
Yes.
raised to 100 degrees centigrade by some heat energy. It transferred to a thin aluminum. That means the cylinder is losing heat. Correct? No. The cylinder is
Yes.
losing it. I can say if cylinder losing it, there is no state change. What is the initial temperature? 100 degrees centigrade. Correct?
Yes.
What is the
Yes,
final?
sir.
Anybody has the what is the final temperature? 20 degrees centigrade.
Yes, sir.
So is it a specific heat capacity? So I get C brass. I put B as brass. Okay. And mass is also I'm putting MB. So let me get this information here. What is CB? CB is given 380 joule per gram degree centigrade. And what is the
Yes,
mass
sir.
given? Mass given is 100 gram. Okay. Now paraffin. Another object is paraffin. Okay.
Correct.
Okay. So it's a so it's saying that aluminium is not absorbing any heat. It's thin aluminium of negligible heat capacity. That means it doesn't absorb any heat energy. Correct? No? Right?
Yes, sir.
Do you understand by this? When you say aluminium, so aluminium is not considered in this heat transfer process. That is the meaning of this. Is that right? Okay. So now paraffin is gaining heat or losing heat?
It is losing heat. No.
What is the initial temperature of the paraffin?
11 degrees
11
11.
degrees
centigrade.
What is the
centigrade.
final temperature of the
So it is
paraffin?
gaining heat.
Yes.
It is
So
gaining heat.
yes, you are right. It's gaining heat. Paraffin is gaining heat. So not losing heat. Mhm. Then no state change. Then what is the initial temperature is 11 degrees centigrade and final temperature is 20 degrees centigrade. Correct? No?
20 degrees Celsius.
And CP I am talking is this paraffin and MP. Right? Hmm? So CP is not known. CP has to be found out.
You have to add.
MP is known. Mass is 150 gram. Correct? And our delta T is delta T1. Delta
9.
T for brass. What is the delta T for brass?
80.
80 degrees centigrade.
Yes, sir.
What is the delta T for paraffin? 9 degrees centigrade.
9.
Sorry,
Okay,
9.
wonderful. Now, we have to apply the principle of calorimetry. Heat gain equals to heat loss. So, what is the heat gain? heat gain, I say that as QG.
MC.
G stands for gain, okay? Some prefix you give to separate from the another information, right? If you don't give the prefix, then you get confused. So you see that all the time I am giving some suffix, not prefix. I am giving suffix because to differentiate from the similar value for of the another object, right? No, correct? Are you getting me? Okay.
Yes,
So
sir.
heat gain is what? Heat gain. Heat gain is equals to M B C P and delta TB.
Delta TB.
So can you guys do the calculation and let me know? I am also doing the calculation with you. So it is. So we do you need to change any unit? You see that we are good. Here also is
No,
given.
sir.
We are good, right? So 150 multiplied by CB, it is 380 multiplied by delta DB, 80, correct? No, right?
150? It's 100 into
I'm
380
sorry, you are right. You are right, very right. It's 100. I took a mistake. Okay, so don't simplify it right now. Do not multiply it right now. Why I'm saying so?
so you can cancel it later.
Yes, you are right. If you multiply it, it is of no use right now, correct? Because the question answer we have to the question that you have to answer is the CP, that is the specific heat capacity of paraffin. So let's look the heat loss. We get a similar heat loss is your QP is heat loss. Sorry, Q heat loss. I say QL. QL heat loss is MP into CP in delta TP. So how much is MP? Is 150. What is CP? You don't know. What is TP? It is 9 degree.
9.
So apply principle of calorimetry, that is QG equals to QC. So what do you get? It would be, so I write the QL, sorry, not QC, QL. So I write the QL on the side because QL we have to got the unknown. So I write it 150 into CP equals to 9. That will be equals to 100 into 380 into 80. What happens to Steve? Srishti has left. I don't know what's the problem. She's facing some problem maybe. So CP would be equals to 100 multiplied by 380 multiplied by 80 divided by 159, correct? Right? All of
So it
you?
is 225.18.
You got the same calculation. How much you
Yeah.
got? How much you got?
225.
225.
225.18.
225 point?
19.
No, 2251 point you
I'm
got,
getting,
no? I think you should get 2251.
yeah, it's 2251.85.
Yes, 2251. You are very right. 225 point. What is the unit?
Yes, sir, it
Joules
is
per
2.
gram degree Celsius.
Yes, joules per gram degree Celsius. Because we started with this only, right? Anybody who has not got. Now, point two. I have a question to all of you now. We got it now, but what was the difficulty you are facing to do this? I gave you enough time.
Yes.
Anybody? Please feel free to that. No, then it will help me to help you overcome these issues.
So we have problems sometimes in the latent part.
Okay, but here why could not do then? What was the problem? Anybody who be honest. Anybody who has some problem here.
Yes, sir.
No? Okay, fine, no problem. No problem. If you are not able to articulate this, not a problem. But let's see that now. Next is the no. Next we are going to do latent heat, including latent heat. Okay, fine. Let's see that. Huh? Let me take it some questions. Okay, let's do this. Let's do this. 13th. Somebody asked me a question. Janani?
Yeah, no, sir, it was also speak.
Okay, fine, no problem.
I just wanted to know your answers.
Okay, no problem. Okay. Are you able to see my board? All of you?
Yes, sir.
Okay. So as usual, all of you just get that table, no? Is the table helpful or it is something difficult for you guys to do
Yes,
it?
sir.
Anybody, because you can always voice your opinion, okay? Okay, simple. What you have to do here? So there is no mixture is here, right? Available, right? It is the heat required to convert a 3 kg ice at minus 12 degrees centigrade to steam. Correct, no? Right? Hmm?
Yes, sir.
Okay. So what do you do here? You get gains heat energy. Okay,
Um,
fine. So it is gaining heat only, but there are multiple states are there. So ice. So what are the states? Minus 12 to 0, ice will remain ice.
Yes, sir.
So no state change. If as I say minus 12 to minus 12 degrees centigrade to 0 degrees centigrade. And it is C again, C of ice
P of I
and
and
mass
mass of I.
mass of ice. Yes. Now again it will be ice. So from ice to steam we have to get, right? So it will, from ice it will become now water. 0 degree centigrade ice will become now 0 degree water. There's a state change, yes. So it will be if the state change, then the temperature, final temperature and the initial temperature will be same. And now we are using latent heat of ice, specific latent heat of ice, correct? And the mass remains same. Now what happens? Now it becomes water. Water, it is again gaining heat. So no state change. It is becoming from 0 degree centigrade to 100 degree centigrade. So in this, it is a specific heat capacity, correct?
Yes, sir.
And again, so
And
what I am doing is, since there is only one mass, I'm just saying m, because it will be m only, right? Mass will remain same. Now, finally, what is happening? Water is again,
water.
so it is gaining it. So state change now. So if you state change, the temperature, final temperature and initial temperature remains same. And now you have LW and M. You have to just pick up each column, each row, and then calculate this. So what is given? CI and M. CI is given as CI. So CI is your
Um,
336, right? 336 kilojoule per
so it
kg.
is the latent ice.
No, first one is the CI. No? Oh yes, you are right. It's a latent type. So it is CI equals to specific heat capacity of ice. The first one.
2000.
Yeah, 2100 joule per kg. Yes. Mass is given. Mass is your 3 kg, and Li is also given as 336. I'm converting to joule. 336 joule per 1000 joule kg, and there is a CW is given. CW is 4200 joule per kg degree centigrade. Then you have the steam. That is okay. It is not LW. It is steam. So it will be LRS. So LS equals to what? It will be 2260 and 3 zeros again joule per kg. So find out Q1, Q2, Q3 and Q4. So Q1 would be M C I. So you look into this. Look into this and then apply the formula accordingly. Ci and the temperature is 12. Temperature difference is 12. 0 minus 12. Correct? No? Yes?
Yes, sir.
You can also,
Yes, sir.
if you want to write it down, you can say delta T here also you can write it down. Another column you can make it so it would be 12 here. Here it is 0. Here it would be what? It would be 100. And here it would be 0 again. Correct? No? That you can write it down. So, and second one would be again M. Q2 is latent heat. So, Li, resort temperature here. Similarly, the third one would be M. CW and temperature change is 100, and the
Yes,
fourth
sir.
one is M. I just look into this. And now once you have populated the table with the data, it's just mechanical, right? No, right?
Yes, sir.
Find out each of these, you find out, and then finally you have to add.
So for Q2, yeah. Yes, sir. Yes, sir. I got it.
1 3.
That's the answer, the total energy required, the total heat required. That's what I'm getting.
You are getting that. Let's see. What about others? I think it should be more. It should be more, Vandita. Let's check. Let's wait for the others.
So,
Hmm. Tell
so
me.
in latent heat of ice, why have you written 336,000?
It is kilojoules, no? Look into here. It is kilojoule.
In latent heat of ice?
Yes, sir. I got the answer.
What do
Oh,
you got? It's 336,000,
okay.
right? Either you convert everything in kilojoules or you convert everything in joules.
Yeah,
Then you can add it. You see here also I've done 2260, then 3 zeros I put because it's kilojoule.
yeah.
Now you have to relook at your numbers. Janani, 756 kilojoules. No. Check the answer.
Answer?
No. So you have 3 kg.
Okay.
Just check the answer one more. 3 kg 2100 into 12. So here you get 3 kg into 336000 is the you'll get it here. M here 3 into CW. CW is 4200 multiplied by 100. Then we get it MLS. ML is 3 kg again, and LS is 2 to 2, 2, 2, 6, then 4 zeros. Right? What you get here? You get 63, so 6,
75600.
7, okay, this is 63, so 6. 75600 is the answer you got, is it? Let me see.
Yeah.
So
Yes,
then,
sir. It is 756 kilojoule.
756 kilojoules. Okay,
Yes, sir.
just give me a moment. Let me quickly do this. So it is 000 and 368 339 0339 right? And what you get here 63 into 12. So and you get it here again 4 zeros, okay, and you get 6 126. Here you get again 4 zeros and 6 7 6. Are you getting all these separately?
Yes,
Did you
sir.
am I did I get anything wrong?
No, sir.
So 1 2 3 1 2 3, okay, so I get 1 2 3, then fourth one, so it will, no, it is 6, right?
It's 9123600.
Yes, you got it right. 91236000. Exactly. Vandita, you got it now. What is the mistake you guys have done? Check it. That is the
I
answer.
I didn't take kilojoule. I just took joule.
What about
I
others?
didn't convert the units
What about others?
before.
Sir, my Q1 was wrong.
That's what. You just check whether I've got it. Yes. So this four terms, it is tallying with you or not. Just check it.
Yes, sir.
Okay.
Only I made a mistake in Q1.
Uh,
It made the whole sum wrong.
what about Preet? Preet, you are there?
No.
Preet is quiet. Preet, why are you quiet? Preet, can you hear me? Oh. Anyway. Okay. Let me see. So shall we move to the next, right? So we'll do one more, one.
Yes, sir.
Have you guys done, no, in the Selena, there are quite a few numericals there. Have you guys done all the numericals?
I don't have
No,
Selena
everything sir.
publication.
Okay, fine. Anybody others who are following
So
Selena?
almost everything are done, sir.
Almost everything. Who has done all? Nobody has done all. Okay, no problem. So we'll do this now. Okay, and another numerical. So this time, okay, what I'll do is, I'll just check. After this, I'll pick up one numerical from your book itself. That is little twisted. So I would see that who can do it. Okay. Yes. Do this again. This time I want to see at least. Now all of you have got the answer. Follow the same table. Same thing. If follow, then things will not be difficult. Arti, are you doing it? Arti, Arti, can I have you with me? Arti is quiet today. Arti, Arti, can you hear me? Hello?
Sir,
Hello?
I can hear you.
Arti, can you hear me? I see, Arti, that you are muted. Can you unmute, Arti? No response. I'm listening. No, I need your help to solve this numerical. That's the reason I want you to unmute you. Can you? I need your help to do this. Or is there any technical issue, Arti, are you facing? Okay. No, my mic is typed. Okay, fine, Arti, no problem, no problem. No problem. Okay. Okay. Preet, I think, has the same problem, I guess. He hasn't responded. Okay. Who has got the answer? Arti, do you get the answer? If you are finding difficulty, anybody just let me know. Otherwise, I'll think that you guys are doing it.
So I'm doing it, sir.
Okay, Janani. Whatever, Vandita, you're doing it.
Yeah, I'm doing it.
Arti, are you doing it? Any issue, Arti? You can respond to the messaging window. You're doing it, Arti. Okay, fine. Good. Good. All of you are doing it. What about Preet? Hi, Preet. Okay. Anybody got the answer? It should not take this much time. Unless you are
Yeah,
confused.
sir.
Yep.
Yeah,
Yes.
so I got it.
Okay, what's the answer?
I got 64 grams, Vandita.
64 grams. Okay. Okay. Who else
Yeah.
have got 64 grams? Okay. Do it me. Okay, Vandita. Let others being done. Okay, let's see what you have done. So who has gained heat? Ice.
Okay.
Correct? No?
No, ice lose it. No.
Ice gaining.
Yeah, ice gains heat. Yeah.
Ice gaining, right? So ice is
Yeah.
gaining 0 degrees. So first it will be gaining heat and it will melt into water. It is right. So there is a state change.
Yeah.
Initial temperature is 0,
Yes.
final temperature is 0,
Yeah.
and you have the latent heat of ice, and mass is 40
Yeah.
gram.
40.
Correct? No? Okay. So
Yes.
then what is after that it becomes water. Correct?
Yes.
Now
Yes.
it becomes water, right? So I'm talking about the water of the ice. Okay. So what happens is, uh, so one question is water is gaining heat.
Yeah.
No, water is this ice water is gaining heat. So this is one part of water. Right, the water which is
Yeah.
converted from ice is only I'm considering right now. It is gaining heat
Yeah.
and there is no state change. It is coming from 0 degrees centigrade to 10 degrees centigrade, and
Yes.
there is a specific heat capacity, and this is also 40
Yes.
gram. Now there is
Yes.
another water where it loses heat. Not sorry. So some water is losing heat, right? So
Yeah.
another a group mass of water which is losing it. Sorry, there is no state change here. There is state change. There is no state change here. Initial temperature is 60 degree. Final temperature is
Yes.
10 degree. It has left. What happened to it? I don't know. Okay. And then what is this here? This will be CW again, and we don't know the mass,
Yeah.
right? So
Hmm.
now what is the heat gain? The QG will be equals to what? The first ice is becoming
Yeah.
40 multiplied
40.
by your latent heat, correct? No?
Yeah. Will be 0.04 because it's 40 grams.
Yes, you are right. That is what I was able to ask you. So it would be, so what you do in that case, we change it here itself and make it
Okay.
0.04 kg.
04.
Wonderful. So it will be 0.04 kg multiplied by 336,300, correct? So how much it is?
Yeah.
It would be
13,440.
0, okay, this is 20 gone, 24, 14, 13,440, right? Joules.
Yeah.
Right. Now another heat gain, this is heat gain 1, heat gain 2 is same ice 0.04 kg multiplied by latent heat of 4,200 joules, correct? No? Multiplied
Yeah.
by change in temperature is 10.
10.
So how much it is? It is
0.4 into 4200.
this much. Uh-huh.
It's 1680. Yeah.
Yes. Now what is the heat loss? Heat loss is M, we don't know. What is this? 4,200 joules, right? And change is
Yeah.
50,
50.
right? Let it be like this, not an issue. We don't need to convert this now because we
Yeah.
have to use this. So again, so what is becoming M multiplied by 4,200 multiplied by 50 equals to, so 13,440, and if you add this, so 13,440 plus 1680. How much it is? It is 0 to
15,120.
6 zeros, 8 for 12, 6 for 1, 15,120, right?
120. Yes, sir.
So that
Yeah.
means M equals to 15,120 divided by 4200 into 50. Now this will give you in kg, right? Understand this.
Yeah.
This will give you kg because you have used all, converted all in kgs, right? So
Yeah.
M is kg here. Now, so you simplify this, gone. So what will you get? So you make it 600. So this will be 2, 1, 6, right? No, 7. I'm taking the 7 only. Okay. So this will become 600. And what is this?
So it is
K
84.
84. Why? I get
So if
36
you
here.
simplify this, it will be 84.
84. No. Let me see. So what I'm with right now. I'm getting 100 into 5 and 36. Right? And this is my kg.
Yeah.
And I'm just converting this into thousand, no, in gram. What I do, 36 into 1000
Okay, okay, okay.
and 100 here into 5. Look at this. This is 2. I get 72 gram.
Yeah.
Yes, sir.
What is the mistake you have done, Vandita?
Um, I did a calculation mistake and I didn't add 1344440 plus 1680. I didn't do that.
Heat gain and, that's what I'm saying. Heat gain and heat
Yeah.
loss. Always do that.
Yeah, I
See,
just did
you
one.
can identify, if you find, see, no, but the good thing is that you found out this gain heat, no? If did you do the
Yeah.
table? Did you use the table or not, Vandita?
Sorry, sir, your voice is breaking.
Okay, no problem. Let me ask you again. Did you use the table? Hello? Am I not audible?
The voice is breaking, sir.
Breaking, is it? Just a minute. Let me check on that. Let me check. Am I audible now? Am I audible now? No?
Yes,
Yes,
sir.
sir.
Okay. My question is, have you guys used this table? All of you? Have you used the table to do this numerical? No? Nobody is saying me anything. Am I not audible?
Yes, sir.
So have you used
Yes,
this?
sir, we use the table.
You use the table. Pandita, did you use the table?
Sir?
Did you use the table?
Yes, sir.
Then you have to just note
Yes,
it, no?
sir.
So always see, we have a specific column, gain and lose heat. So you have to compute the gain together, compute the loss of heat together, and then equate it. Okay, good. Okay, Janani, who is following concise publication?
Yes, sir.
You follow this. So I am picking up on
Huh?
numerical. Janani, do you follow concise? Selina,
Yes, sir.
this is the example from your book. Not example. This is the numerical from your book. Have you done this? Or do you remember that whether you've done this or not?
So we can't see the question.
Yes,
Oh,
sir.
you can't see the question.
Just still.
A lot of problem today. Anyway, sorry for you guys. So your the screen change has not changed for you guys, is it? Hmm? No.
Yeah.
So let me refresh my window. Just a minute. Let me refresh my window.
Yeah.
Yes, sir. Yes, sir, it's visible.
It's visible now, but it's not visible to me now. So there is again a problem. So I need to.
Yeah, no, sir, it's not visible.
It's not visible, no?
No, sir, it's not visible.
Yeah, yeah. I could figure out. I am not able to see myself. Oops. I'm just refreshing once again. Can't help. I'm refreshing for the third time. It's taking some. Yeah, I'll type the problem down. Yes, Janani. Just giving that. Okay, one more time. I'm just trying to upload to the screen right now. If it doesn't go, I'll type it. I'm just chatting with the technical team. What they're doing. Is it visible now? Are you able to see my screen? Yes.
Yes, sir.
Is
Yes,
it?
sir.
Is the question visible to you
Yes,
guys?
sir.
Yes. Okay.
No, sir.
No, sir.
No.
Question is not visible, sir.
Question is not visible. Now Aarti is saying yes, sir. Question is not visible. No. No, sir. Again.
No, sir.
Okay. Okay. I'm just typing the question. Fine. 1 minute.
Now it's so we can see it now.
You see it now?
Yes, sir. It is
Okay.
visible
Wonderful.
now.
Okay. Fine.
Yes, sir.
Yeah. So let's try to do this. Some success. Okay. Yeah. So what do you understand from here? This is little twisted now, not very straightforward. Some understanding is required. This type of numerical little hard. Yes. Who can explain your understanding? Someone needs to explain what you understood. Janani or Vandita, I don't say. I think some people have left because of the technical issue today.
We have to find the temperature of the mixture, the final temperature of the mixture.
No, it is asking you. See,
Yes, sir. We need to find final temperature of the
find the
mixture.
result of mixing, not final temperature. Result. What will happen? What will happen? You have to find out not only the temperature, but also to say whether all the ice will melt, or if at all the ice melts, what will be the final temperature, everything. Did you
So,
get that?
voice is
Sorry? My voice is breaking.
yes,
Yeah.
sir.
Oh. Okay, so let me try.
So,
Is it better now?
how it is audible, sir?
It is audible. So you have to
Yes, sir.
find
Yes.
out what will happen in this mixture. Whether it will have all ice will melt, or some ice will melt, some ice will not melt. If at all ice are melting, what will be the final temperature? If some ice melts, some ice don't melt, we know the temperature would be 0 degree. So that is what you have to find out.
Yeah.
How to do that? Again, we follow the same default method what we have learned today. Okay. So what we do?
Okay.
Who is getting heat? Obviously, ice.
I will means heat.
Ice.
Ice is getting heat.
It will
Now,
not
sorry.
minus 10 degree.
Yes,
It will
ice is.
not change its state.
So ice will gain heat. There could be two outcome. One, first is before it becomes melts into water, it has to increase the temperature from -10 to plus 0
0
first.
degree.
So -10 degree centigrade to 0 degree per centigrade. Right? Let's see. So there is no
Yes,
state
sir.
change. Li is given. It is not Li. Ci.
Yes, CI.
Ci
CI
and
is equal to 2.1 joule.
yes. So it is
kg
10,
per,
10
I mean,
gram mass. Okay, next ice will gain again heat, but this
Ice,
time
it will change to water.
it will change to water, state change. So 0
Yes,
to 0, 0 to 0,
so it is
and
latent heat
latent heat.
336.
So, but we don't know. We can say, for example, we say that entire, assume that entire ice is melting into water. Assume it could may not, maybe or may not be. We'll see that. We'll see that it may or may not be. Correct? No. Now, what will happen to water? Who is giving the heat, supplying the heat? Is the water, right? So water is
Yes.
supplying it. So water is not gaining. Water is to lose.
Yes, sir, it will lose.
It will lose. Now, water lose, no change. So what will happen? It is from 10 degrees
0
centigrade,
degree Celsius?
0 degrees Celsius,
Yes, sir.
correct? So it will be,
Sir, it is the other way. It is the
no,
other way around.
why other way around? Water is 10 to 0, no?
Okay, it has to come down. Okay.
Yeah, it is losing, no? Look into here, where, in which column we have put it? We put it here, right?
Loses heat.
Yes. The mass, mass is 10 grams.
Mass is 10 grams.
Okay. So let's see that what happens. So, let's see what is the first one. Q1 gain. What will happen here? Here it is the, Ci. So M equals to 10 gram. We do not need to convert this gram because the unit is also given in gram only, right? And Kelvin and per centigrade is same, correct? No? Both, all of you know, right? So
Yes, sir.
Q1 gram, here it is, will be, let's consider the 10 gram of ice multiplied by what? 10 gram of ice
2.1.
into 2.1. You are right.
2.1 into
Yes.
10.
So this would be 21. No, this is 21, right?
Sir,
One.
into 10 again.
No, okay, this is the Q1G. Yes, it will be, so it's basically Q and 10 again. You are right. So it will be 210 joules,
Yes,
right?
sir.
Okay. Now Q Q1, so Q2G. So Q2G is a
Degree
state
Celsius.
change. State change is
10
equals
plus
to
into 336.
10 to 336.
336.
So 3360 joules. Now let's see whether how much water can supply. So Q loss. Loss is
10 into 4.2 into
10 into
10.
4.2 into 10. So you get 420. Now look into here. We know the principle of calorimetry has to be followed. Now you see, if the ice entirely
Sir,
melts
your
into,
screen is not visible.
my skin is not visible.
It is stuck. It is stuck, sir. It is
Stuck.
done.
It is stuck. Okay. Now you see here, what is the so what is that you are finding here is Q1 and Q2. These are the gains. Now, can the water supply this much of heat what the ice needs to melt into water? Can it?
No.
Is my skin still stuck? Is my skin still stuck? No.
No, sir.
Okay. So look into here, all of you. Can water is losing. So water is not able to provide the amount of heat required by the ice to melt into water. Correct? No? So that means,
Yes, sir.
so if you
It
look into,
cannot get.
yes, so basically Q loss would be Q gain. So out of this, what is happening is, so I cannot take Q gain both together, right? So this is Q loss. So Q loss here 420 equals to 210 will be taken by this, and plus there will be another 210 left. Correct, no? And this 210,
Yes, sir.
this 210 is ice converting from minus 10 to 0.
Please,
Correct?
please, John. Yes, sir. Yes, sir.
Now what will happen to this 210? This 210 will melt some ice into water. Correct, no? To convert, to
Yes,
melt
sir.
entire ice into water, you need 3360 joule. But that is not, the water is not losing that much of energy, because this is what, this is also water becoming 10 to 0. Did you all of you get the question here? Are you getting me?
So, can you tell it once again?
Sure. If you see that what we are trying to expect is, we don't know result. When the result we don't know, we are seeing that if entire ice melts into water, that is from minus 10 to 0 degree centigrade water, then what is this? This will remain minus 10 degree centigrade to 0 degree centigrade of ice. Correct, no? This
Yes,
is
sir.
minus 10 to 0 degree centigrade of ice, sorry.
0 degree centigrade.
And what is this? It is 0 degree centigrade ice to 0 degree water. Correct, no?
Yes, sir.
So now this heat required by the ice should come from where? Should come from water, right? Correct,
Yes,
no?
sir.
Now, can the water, how much water is losing? If the water is to convert, water has to no, reduce the temperature from 10 to 0 degree, it is thus losing 420 joule, right? So 420 joule is just enough to convert the ice from minus 10 to 0 degree, because it is taking 210 joule. So you are
Yes,
left with
sir.
how much? 210 joule. So
Another 220, sir.
yes, you see that in all
Yes.
these three heat, the temperature remains same. Correct, no? The ice is also 0
Yes,
degree.
sir.
This is also 0 degree. This is also 0 degree, right? The final temperature is remain same. You see, look at your table. We have considered the final
Also 0
temperature is
degree.
the same. Correct, no? Right? So now we are
Yes,
comparing,
sir.
is in Sustai's cup. Is everything, no? Is all the, whether entire ice has melted or not, we are checking. For the ice to melt into zero, for the ice to melt, it needs additional of 3360 joule, and water can only supply 210 joule. That means what? This will melt only some part of ice into water. Remaining will be remaining will be in ice state only, right? Correct,
Yes,
no?
sir.
So by these 210 joules, how much ice can be melt? So that means ice needs ice needs how much? 336 joules per kg, right? No, to melt into water.
Yes, sir.
Is it not? Correct, no? That means what? 1 kg, 336 joules, 336 joules needed to melt 1 kg ice into water, right? No? That means,
Yes, sir.
so 210
Yes,
joules
sir.
will be needed to melt how much? So it's 336 joule per gram, not 1 kg. I'm sorry. It is not 1 kg. This is per gram. Correct? No? Right? No?
Yes, sir. It is also
So
gram.
yeah. So it is basically how much? It would be 210 by 336 gram. How much it is? Hmm?
So just 1 second.
How much is it? Okay, you're doing it.
So it is 0.625.
0.625 gram ice. So what is the result? The result I can say, you're able to see my result is what? The mixture temperature, the final temperature of the mixture is 0 degree, right? Final temperature is 0 degree centigrade, and only 0.625 gram ice has been melted.
Yes, sir.
Remaining ice remain in the ice state, correct? No? So this is the result. Anybody who has not understood, I don't mind explaining it again. Please feel free to ask me. Anybody. Srushti, what happened? You are not there for some time. Srushti, are you there? Srushti. Srushti, can you speak? Okay, I think let
So
us
can you
speak.
just
Yeah,
scroll
please.
it?
Can you just
So can you just scroll it down?
scroll down?
Yes, sir. Thank you, sir. Thank you, sir.
Okay.
I just took a screenshot of that.
Now, anyway, I'll get the recording of this, not an issue.
Yes, sir.
Okay. Anybody who has not understood, please feel free to let me know. Okay.
So no problem.
No problem. Okay. So this is little difficult. You understood, right? But the thing is that, do you see this table may be again helping us, right? Correct? No? Is it helpful or it is useless?
Yes, sir.
Some
No,
of
sir, it is helpful.
Okay, now Aarti, some of you, most of you yesterday told me that you find this calorimetry difficult. Is it still difficult? Do you find? I picked up some of the easy questions, some of the medium type, and some of the difficult questions. Do you find this easy or difficult? Still,
Sir, if the questions are a little tricky, it is difficult to solve. But
needed to say
actually,
that again.
so if we understand, it is easy to solve.
No, but see, only part here
If we
to
understand,
correct. Only part here to understand to answer your question. Only part to here understand. First, you see
and
who is gaining
these are the
and
data on the table.
yes, who is gaining and who is losing. In the process of gaining or losing, is there any state change? So you have to capture that. And each different, for state change, you have an entry in the table. For losing, you have an entry in the table. For gaining, you have to enter in the table. And then you pick up those heat energy according to that entries. Right? No? So if you can populate the table appropriately, you can only way you can make mistake is by calculation mistake, which you have seen earlier, right? No, so only way you can make a mistake is calculation mistake, because your calorimetry will be around you. Tell me any problem that you could not do. Now, if you go and look into those problems, you'll be able to solve those. Forget about the ones you have not seen it. When you say the calorimetry was difficult, yes,
Sir, I just have a question.
yes.
Can you just tell me how to solve it?
Which one? This one?
No, sir. I have a different question actually.
Please, can you message to the on the board?
Yes, sir.
Just message on the board. I'll just pick it up and then put it here.
Yes, sir.
A piece is dropped into, okay. So I'm putting on the board as well for everybody's benefit. Mm-hmm. Yes, Janani, what next? You can tell me also. Probably if you find this typing difficult, I'll type it on the board. Yes. What is that? Is that all? Are you guys there?
Now, they're given the specific heat capacity of water and the specific latent heat of fusion of ice.
Okay. So what you to find out? After all, okay. Calculate the final temperature. I'm getting the message
Yes,
late.
sir. It's okay, sir. Sir, it is given a specific heat capacity of water is 4200 kg per 10, no, yeah, it is kg per Celsius,
Hmm.
joule kg per Celsius, then specific latent heat of fusion of ice is
Three, six. Yes.
336, 336 into 103 kg
Okay.
per, joule per kg
So specific latent heat. Okay. Let me write it.
of fusion of ice. Specific latent heat of fusion of ice.
I'm just setting in short. 336 triple
Yes,
zero. I
sir.
know that. Joule per kg.
No,
Correct. No?
they've given it as 336 into 103.
That's okay. That's okay. 336 one. We'll take it only. Is that all?
336 into 103.
Into 1, no. It is 10 to the power 3. Sorry. That is 10 to the power 3. It's
Yes,
3006. Okay. 103 is
that's
not there.
right.
10 to the
That's
power
right.
3. Okay. Got it, no? Is that all?
Yes, sir. Yes, sir.
So just let's take our table. I always follow the table. I'm not sure whether you guys find it comfortable, but I find it very comfortable. It makes my life easier to explain as well as to do the numerator. So let me do this here. Let me put it on the board. Let me reduce the size. Okay, Janani, why did you find this difficult? Let me see. A piece of ice, we don't know what is a piece. A mass 40 grams, okay? So what happens is ice is gaining heat, no? And
Yes, sir.
so ice is gaining heat. There is a state change first
There is,
because I am considering the ice is at 0 degree centigrade. Which is not given,
okay.
right?
If
So,
there is something minus,
sorry?
if the temperature is minus 10 or minus 12 degrees Celsius, then no change of state, and later on it will
No.
be a
That,
change.
yes. First you have to come down to 0 degree centigrade. That is the what is that? Melting point, correct? No? There is a melting point.
And then
Then you have to
the
change
state.
it to the specific. That is the temperature increases. No, correct?
Okay.
So
Here
here,
I didn't know where to use ML and where to use MC delta T. That was the main problem.
is it clear now?
Yes, sir.
You know how to do this now. Let's do it quickly.
Yes,
At
sir.
least we'll frame the equations. We can solve it later. Okay.
Yes, sir. Yes.
So 0 degree centigrade is the initial temperature. Final temperature here is state change. First is this state change. So here is you are going to Li and mass is given. Mass is 40 grams. So you'll get 0.04 kg because it is all given
Yes.
kg, no, right? So 0.404 kg. Now ice, we don't know the final temperature. We have to find out the final temperature. So ice gaining heat again, not ice. Sorry, this will be water now.
It is using heat.
So it will be water now. So this water is the from the ice water.
Okay.
Okay. So so what is the
It will
water?
be a
It is loose, so there is no state change. So from 0 degree, we don't know the final temperature. So we make it T2 or just T, just a T. Huh? We make it capital
okay.
T, capital T. Small t is the time. So capital T, and this is your specific capacity, and then is 0.04 kg. Now there is a water has been added. So water, the other water is losing it, right?
Yes,
No.
sir.
So it will be no state change again. So 50 degree it start and it will be final degree temperature is 50. So T, correct, no? Right? And here
Yes,
we are going
sir.
to so it is CW. I'm sorry, it is CW and it is 0.2
It is
gram,
200, sir.
0.2 kg.
0.02 gram.
Okay,
Sorry, kg.
now capture this. So the first two cases gain heat. So I said QG. So QG would be in the first case 0.04 multiplied by 3000 336, right? Correct, no? Latent heat
Yes, sir.
plus 0.04 multiply 4200, and I don't know, it will be T, correct, no? T minus 0 is T,
Yes, sir. T.
the first case here. Now, what is the loss? Loss is 0.2 multiplied by, what is this? Specific is 4200 multiplied by,
200.
we don't know, it is T minus 50 minus T,
T minus.
50 minus T, the loss, no?
Okay. 50 minus T.
Now you equate these two and you solve for T. Can you do this?
Yes, sir.
That's it, no?
I actually didn't know where to use MC delta T and where to use ML.
Right. So you
So that
all,
is the main problem.
yes, very good. So you,
So
if you
with
use,
this table, it is clear now.
yeah, that is what is the purpose of the table. I am happy that you just realize the table is so helpful. Okay. Okay. Anybody has any other question on this? Who is still finding difficulty with calorimetry? I want to know. I want to know, and I just want to find out why are you finding it. Aarti, can you? I know you have a mic problem. Can you just tell me, Aarti? Do you still find calorimetry difficult? Please give me an honest answer. Doesn't mean that you have to be forced to say everybody is saying yes. Please give me an honest answer. I sorry I could not talk to you today because you have mic problem. So I would love to have you and then do this numericals. Aarti, you can message me. Srusti, again we missed you today. What happened, Srusti? You are not there for some time, right?
The yes, so the internet problem.
Yes, Srusti. You had this calorimetry problem, right? I missed you because no, you wanted to do that. Now, Srusti, probably sometime we need to find out how can I explain this to you again. I know, I think you missed quite a bit, right? And we also had our own issue here, technical issues we suffered as well because server was not helping us. So Srusti, did it did you get anything out of this today because of whatever the technical issue, or do you need a separate you need to needed another session to do it? I just check it with Vedantu. If it is possible, then I'll do this for you. Susti, you got anything today?
No, sir.
I know. Susti, okay, fine. I'll just,
Sir,
yeah, please, Susti, tell me.
sir, I have a doubt in yesterday's class.
Yes, Janani, tell me. Yes, all of you
Actually,
tell me. Yeah.
I have a doubt in the mechanical advantage and the velocity ratio of the inclined plane.
Okay. Yes. So what is the
I
doubt?
I didn't understand how to find it. The derivation.
Okay. Do you know how to find the mechanical error for a
So the
okay.
derivation of the mechanical advantage.
Okay.
The
Okay.
derivation is
Let me
simple.
ask the group. The group does all of you, I mean, feel that there is a problem, do you find this difficult what Janani has said, or others are fine with it? This
No.
you don't find difficult, is it? Right?
No, sir.
So with your permission, can I just quickly take 2 minutes and then 3 minutes to explain this to her?
Yeah.
Fine,
Yes, sir.
Yeah.
no problem. I'll just quickly tell you, Janani, it is not very difficult. Only thing you to identify find out the angle. So I'll just get it on the board and to explain that to you immediately. Just not taking much time of the other side. Look into this, right? Is it visible to you? Let me reduce this a bit.
Yes, sir.
Okay, so Janani, be with me. I can
Sir,
explain.
actually,
Not visible?
yes, sir, it is visible.
Look into here. So,
Yes, sir.
okay, fine. This is the basically inclined plane. You see, this is a theta. See, if this is a theta, do you know how this becomes theta? This angle,
Huh?
this theta. You get how this becomes theta? See what is happening in the incline. Let me quickly tell you. There is an object on the plane, and you have to lift it along the inclined plane, right? No. Now the
Yes, sir.
object is along the inclined plane. Now this object has got a weight which is mg, correct? No, right?
Yes, sir.
An object is moving along the plane. So on this on the reaction force, so there is no movement on the vertical to the plane, correct? No, because the movement is only along the inclination of the plane. So you know that the force, there is no force acting vertically, otherwise you would have moved along the vertical direction, correct? No, right?
Along the inclined plane.
Yes. So it is only moving along the inclined plane. So
Yes, sir.
that is the reason the force is acting only along the inclined plane.
So your
Now,
voice is breaking, sir.
yeah, my voice is breaking. Okay, fine. Let me check. Okay, is it better now, Janani? Now, is it better now? Is it better now?
So your voice is breaking.
No, it's still better. Still bad. Janani is still bad. All of you. Hello. Am I
Yes,
audible?
sir.
Is it better? No.
No, you're not audible.
Not audible. Okay. Can't help much. Not audible. Seems to be some issues. Am I audible now? Am I audible now? Am I audible now? Janani?
Yes, sir.
Am I audible? Okay. Good. So Janani, just have 5 minutes left, I think.
Yes, sir. Yes.
So
Yes,
what? Yeah. So do you under? So what? There is no force. There is no force along the vertical direction of the this inclined plane because there is no movement around that, right? So only force is along the inclined plane. That means the reaction force provided by the plane, which is vertical, which is along the no the vertical direction of the plane to the normal to the plane, and the cos theta component of the mg. This the mg is the weight, right, Janani? Correct? No.
yes, sir.
So this should be equal to this because otherwise no there would be some movement along this direction. There is no movement. It is only moving along the inclined plane. So
Yes, sir.
what is the force along the inclined plane? This is the mg sine theta, right? No.
Yes, sir.
Okay. Now, what is, look into sine theta now. If this is sine theta is BC by AB, opposite to the by hypotenuse, correct? No? So BC by AB I
Yes,
got.
sir.
What is sine theta?
It is
H by L. This is H and this is L,
H
right?
and this is L. Yes, sir.
Now, look into the mechanical advantage. Load upon effort. What is the load? Load is the weight of the object that you have to lift. How much effort you have to put?
Yes,
This much effort, which is equals to mg
sir.
sine theta, correct? No? Right?
Yes, sir.
So mg by mg sine theta becomes 1 upon sine theta. Now you get what you
L
get?
by H.
L by h. So here h is not
Okay.
hypotenuse, h is the height. L is the this length of the plane. Are you getting me?
Yes, sir.
Is
Yes,
it
sir.
is it clear now?
Yes, sir. Yes, sir.
Okay. Fine. Okay. So I'll do one thing to all of you. I'll just stop here and just let me know what I'll do. I'll just check with Vedantu so that we can, in some days we can have at it. I'll just whether we get another half an hour more so that we can cover up these technical issues that we had today due to the server. And so now what I'll do is, I think Vandita, you asked me about in the you only told me, right? You had some issues with some of the numericals,
Yeah.
right? So please mail this
Yeah.
to me, Vandita, all of you, not only Vandita, all of you, go through the assignment, mail it to me, which that you have not understood. If if it is not required,
Yes, sir.
it is a simple answer, I will mail it back to you. If requires under
Okay.
explanation, then I will
Yeah.
definitely pick up in one of the sessions. So yeah, we are meeting
Okay.
again in the next Tuesday, and next Tuesday we are
Yeah.
going to do what? Next Tuesday we are going to do. Let me see what I have planned to do that. Okay. We actually have planned to do sound today, but unfortunately we lost a lot of time today, and so we can't do this. So do we will do light, the next session.
Okay.
Okay, so
So we'll
light
have your session on Tuesday.
on next Wednesday. Yes, next Wednesday. Okay. So what I expect from all of you is please go through the assignments, and please use those questions for your preparation about the chapter, knowing the concepts. So similarly now I am going to share this the questions for your light chapter so that ensuring you that you know the concepts. When you come prepare with the concepts or the basic concepts, it's much easy to do the question answers, the board level question answers in the session. Correct? No? So that is what I
Okay.
want from all of you. I need that. Please make use the maximum out of this these very sessions that we have. Then it would be, it definitely will get good results, surely. Okay. And if you have any conceptual, like Janani has pointed out today, I think yesterday also, somebody has asked about this, how the, I think it's the Sushti, right? Asked about how the watch works. So such questions, if you have, if it's bugging you, something in the book you are not able to understand, please feel free to ask me. Do not need to bother know that it has to be specific to that concept. You just shoot a question to me, either email or in the session. I'll see that whether I can explain in any of the sessions, or probably I can take some additional sessions for all of you to explain those. Okay, makes sense? Hmm?
Yes, sir.
Fine, then we'll close it today now, and hope you got something. Sushti, I'm feeling bad for you, but I'll try to see that how can you make it up. Okay, and okay, fine then. Good night to all of you. Right? Hmm?
Good night, sir.
Good night. Bye bye. See you in the next
Bye,
session.
sir.
Bye bye.